This question, we will look at a worked example, and we'll begin by asking ourselves what type this is and trying to visualize the situation before us. So we're told we have a bowling ball rolling eastward. So right away, that tells us we have a coordinate system we need to set up. And we have our positive direction, our negative direction, and we have eastward, and by convention, we usually make east positive and west negative. So we have a bowling ball rolling eastward. It's moving toward the east, and it's going to collide with something, so probably we should draw it over here on this side. 7 kilograms, and it's heading eastward at 4.0 meters per second. It's headed eastward, so the velocity is positive. It collides, so our type is a collision, not an explosion. With a different bowling ball headed westward. So this is a 4 kilogram ball headed westward with a velocity of minus 6 meters per second, and it's minus because it's headed in the negative direction. So we're told after the collision, the 4 kilogram ball is headed eastward at 2 meters per second, so its velocity is positive. So we want before and after diagrams, but we've pretty much done this. We have our 7 kilogram, and we don't know if it's going to move in this direction or this direction. At the beginning, we are asked to predict that. And then we're asked to determine the velocity. Now, the thing to keep in mind is the AP won't ask you to actually perform a calculation like this to get the answer, but you would need to set it up algebraically and so forth. Of course, we'll consummate that calculation with a final answer, but we're more focused on setting it up and understanding the physics behind it. So we begin with P0 equals P, and beforehand we have momentum of the 7 and momentum of the 4. And afterward we have the momentum of the 7 and the momentum of the 4. Now, the momentum of the 7 is M7 V7 plus M4 V4. And afterward, we have M7 V7 prime plus M4 V4 prime. Now, I didn't put a prime on the M7 and the M4 because the mass stays the same. There is no different value afterward. The unknown that we are looking for is V7. So we want to come up with an expression for V7. Our first step will be to subtract this term. So that gives us M7 V7 plus M4 V4 minus M4 V4 prime. And that then will be equal to M7 V7 prime. Now to get V7 prime, of course, we must divide both sides by M7. So now we have our expression. With these momentum calculations, what we're doing is an accounting. Since we have a law that things must be preserved, we're just checking and balancing and finding out where it all is and where it's going. So let us do the calculation. We have a mass of 7 beforehand, and the velocity is 4. For the 4, the velocity is 4. Or the mass is 4, but the velocity is minus 6. And afterward, we have a mass of 4, but the velocity is positive 2. And that is all over a mass of 7. Well, our terms are 28 minus 24 minus 8, all over 7. So V7 prime then ends up being minus 32, and 28 is minus 4/7, is V7. So we end up with the calculation telling us that the velocity is minus 4/7, which is about minus 0.56 meters per second, I believe. So this is the expression that we came up with, V7. We could compute individual answers at this point in time, but let's check ourselves to see if we're correct. Ultimately, if we are correct, then the momentum before will be equal to the momentum afterward. Let's calculate the momentum before. The momentum before was 7 times 4 plus 4 times minus 6, which is 28 minus 24, which is 4. So the momentum before was 4 kilogram meters per second. Let's check the momentum afterward. We have 7 times the velocity of minus 4 sevenths. And we have a mass of 4 times the velocity of 2. So we are left with minus 4 plus 8, which is 4. Does 4 equal 4? Yes, it does. And so that is how we can check our answers.